All right, so this time we're still doing function composition, where we take something from one function and plug it into another function. But instead of it being like a number, that you're plugging in, it's actually going to be, we're going to leave it in terms of x, all right? So we're actually going to take a function and plug it in for another function. So if I had asked you to find g of 2, you would have went up here to the g function and replaced the x with a 2. All right, well now we're not putting a number there, so we're actually plugging in f of x, and this is f of x. All right, so to find g of f of x, we're going to go up to our g function and replace that x with this whole f of x. All right, so instead of an x, we're going to be putting 2x plus 3. Let me show you what I mean here. So 2x plus 3 plus 1. All right, so we went up to the g function and replaced that x with this whole f of x. All right, so this is like the x plus 1. And then all you do is simplify this. Drop the parentheses, and then 3 plus 1 is 4. And that's it. Okay, let's try another one here. This time we're doing, if I rewrite that, instead of g composed with f of x, we'll just say g of f of x. So we're going to go to the g function, so go up here, but replace that x with f of x, which is this whole 3x minus 5 mess. All right, so it's going to start off with negative 2, and then instead of an x, we're putting this whole f of x in. So 3x minus 5, and then we have this plus 7. So it's negative 2, and then this is the x right there, and then plus 7. What you do is distribute the negative 2. So this becomes negative 6x, and then negative 2 times the negative 5 is plus 10, and then plus the 7, and then just combine those two, and you'll get negative 6x plus 17. All right? So this is one of the crazier ones here. We're doing f of g of x. So we're going to go up to the f function, and wherever we see an x, we're going to be replacing it with g of x. All right, so wherever we see an x over here, we're going to replace it with 3x plus 2. So we have 3x plus 2. So all that squared, that's just like the x squared part, plus 5, but we're replacing the x with a 3x plus 2, plus 2. All right, so it's x squared, but instead of an x, we're putting 3x plus 2. Then plus 5, but instead of an x, we're putting 3x plus 2. And then there's the plus 2. All right, so now we would have to simplify this whole thing. I think I do have a question on the test kind of like this, but you would actually just leave it at this spot right here. I'll work it out and show you how to simplify it. Let's say we did, it would be 3x plus 2 times itself, and then we'll distribute the 5 in, so this will be 15x, and then 5 times the 2 will be 10. Okay. Let's see here. We're going to multiply this out and combine those terms. So 3x times 3x will be 9x squared. 3x times 2 is going to be 6x. 2 times 3x is going to be 6x. And then 2 times 2 is going to be 4. All right, that was all that part. And then we have the plus 15x. And then 10 plus 2 is 12. All right, we got to combine all these terms now. So this is the only x squared term. As far as the regular x's go, we've got 6x, 6x, and 15x. So that's 12 plus 15 is 27x. All right, and then our regular numbers, you got 4 and 12, so 16. There we go. So I know it's kind of hard doing the actual evaluating part, simplifying it all, but this is the only part that you're going to have to do, I believe. All right. I might be wrong about that, but check your homework, check your assignments. Just mainly it's just a plugging them in part.